Good morning, students. We will continue the previous class. In that previous class, I was saying you about the simple microscope. Okay. Here, I was saying you about that one only. Simple microscope is a single biconvex lens. See, when we going to observe the small object, as I said, we holding like this. Our eye, here lens is there. We moving like this. Moving like this means what we are doing exactly there. We are taking that object whose image we want. We are taking that object in between the optical center of that lens and its principal focus point. This is optical center. This is principal focus point. Object should be held between these 2 points, then only that biconvex lens can able to produce virtual erect magnified image. To get that condition, we are doing it like this. Doing like this means what? We taking the object between optic center and principal focus point. Getting what I mean to say? When we take that lens close to our eye, at that time we unable to see the image clearly. What we are doing? We taking that lens near to that object. Near to object means this object should lie between its optical center and principal focus. That is the arrangement what we are doing by like this. Okay, look here. Once that object AB came between optic center and its principal focus point, then it is going to produce virtual erect magnified image. That already we do. To get a ray diagram, we have to take 2 light rays. One is parallel, okay, from that object. This is a light ray. A parallel with respect to principal axis. After refraction, that is passing through the principal focus point. Okay, this is a light. A parallel light passing through the principal focus. Then one more light ray from top portion, which is passing through the optical center, which is not going to deviate, which is going to continue its path. These 2 light rays from the top portion of that object got received by your eye. These 2 received light rays, how they looking? They looking divergent. Here these 2 light rays are looking divergent. Here they are not going to converge. For you, these 2 light rays are diverging means what? From somewhere your eye will feel like that. From somewhere these 2 light rays came. From one particular point, these 2 light rays came. Like this, your eye will feel. Yes, to get that somewhere point, what we have to do? We have to extend in a back direction. I mean, we have to go in backward direction along with those refracted light rays. You go in backward direction. Take the backward of this one and take the backward of this one. These 2 light rays looking like came from this portion. Here there is an image of this object. For you, these 2 light rays are looking like came from this position. Mean your eye feel here there is an image. Getting what I mean to say? This is the virtual erect magnified image. You see the size of height of object and image. Okay, this is upright. This virtual. Why called virtual? We feel it is there. Really, it is not existing there. We feel like that. So virtual, it is upright, called erect, and it is magnified. We understood. One more thing is there, very important. This image formation. Okay, we may get it anywhere between that near point and far point. By doing adjustment like this, by changing the position of lens or object. By placing the lens constant, you may move the object, or if you want to fix the position of object constant, you can move the lens. You go with any adjustment. Getting what I mean to say? See here, what I mean to say. This is the movement of lens, this lens. By doing like this, okay, we may get that image at near point or even at far point. First case, here we go with two cases. Firstly, we are going to get that image at near point, and secondly we are going to get that image at far point. What it means? See here, near point is what? From our eye, that near point is at 25 centimeter. Try to get here. This is my eye. This is the 25th point. This is 25th centimeter. Here object is that. This is object. And this is the lens. This is my eye. Here this is the lens. Okay. Somewhere behind object there is a virtual image. Behind object there is a virtual. This is object. Like this type of layout, okay. This blue color marker is object, red colored marker is lens, and this is my eye. Getting what I mean to say? By doing this adjustment, okay, here somewhere behind the object we getting the image. Getting? See here, by changing the position of lens, now we are going to get that image at 25 centimeter from our eye. This is my eye. 25 is here. The image of this blue marker we are going to get exactly at 25 centimeter. This black now is the image which is at 25 centimeter from my eye. This is image. This black is image. It is exactly at 25 centimeter from my eye. To get this image at exactly 25th centimeter, we did some adjustment here. Getting what I mean? By doing some adjustment, I mean by moving the position of lens, we taken the image of this object at 25 centimeter. Getting what I mean to say? Here in this diagram it is there. We moved this object AB between optic center and principal focus, and finally we got the image of object AB at 25 centimeter from our eye. This is lens. We imagine exactly behind of lens we are there. Lens means behind that lens only we see. Getting what I mean? This is the 25th centimeter. First case. See. We got the image A dash B dash at near point by adjusting the position of lens or object. Anyone you can adjust. Getting? See here. This A dash B dash is the image produced at D point. This image subtended certain angle at your eyelids. Here you are weaving like this. Okay? This is the ray which is coming from the top portion of that image. This is the ray which is coming from the top portion of that image. Look here also. This light ray, it subtends an angle beta at that lens. Beta is the angle subtended by the image A dash B dash which is formed at near point. Okay? Look here, this is beta. Getting what I mean to say? Yes. Similarly, beta is the angle subtended by the image at the lens. Now, imagine that. See, suppose this lens, that lens is removed. Look here. This is object. This is object. This is lens. My eye is here. Okay? With the help of this lens, we got the image at 25 centimeter. Okay, 25 centimeter. This one. Suppose if you remove this lens, now you focusing on that object. Now object, when you focus, okay, when you got image at 25 centimeter, then object is between 25 and optical center. Getting what I mean? Now image itself is at 25 centimeter. Object is here. Your eye is here. If you remove this lens, then what will happen? You unable to see this object. Why? Because that object is in between that your eye, optical center and that near point. Getting? One thing you don't get confusion. Imagine this eye exactly is here. Imagine this is your eye. This is your eye. You are here only. Behind this lens only. Behind that lens only you are. Looking like this. Okay. When you looking like this, from your eye of that lens, at 25th centimeter you got the image. Okay. If you take away this, if you remove this lens, then that object is very close to your eye. That object is between near point and your eye. At that time, you are unable to see that object because it is between our eye lens, optic center and near point. Up to near point only, this our naked eye can see the objects clearly. Our naked eye. With the help of that additional lens, with the help of this additional lens called microscope, you got its image. Once this simple microscope or that additional lens is removed, then you unable to see that object AB. You are unable to see that object AB because it is between that near point and optical center of your eye. So you can't see. So to see the object, to see that object, minimum it has to be at 25 centimeter. Getting what I need to say? Now you imagine like that. Without any optical instrument to see that object, with your naked eye, that object at least at minimum distance. I mean at near point. That imagination you see here. Now here this, look on this diagram. This is your eye. This is your optical center. Eye here only. From your eye, that object will be, when it is at d distance, when it is at 25 centimeter, then only you can see that object. Getting what I mean to say? Yes. See, this is your eye. Okay, from your eye, that object has to be placed at 25 centimeter, then only you can see that. Okay, without any optical instrument, without a simple microscope to see that object, it has to be at D point. You placed that, you imagined that object AB is at D point. Okay, now you see here, when you place that object at D point, then that object also made an angle at I. That angle is alpha. Here alpha is the angle subtended by the object which we imagined placed at D point and viewed through naked eye. Getting what I mean to say? Alpha is the angle subtended by the object and beta is the angle subtended by the image. Getting what I mean to say? So now you see here, this our ray diagram is giving that image is formed at near point. Here there are two cases. Look here on this first one. I have written case 1. When formed at near point. Near point already we called as capital D. Least distance of distinct vision. Okay, I mean at D point. Here we talking about magnifying power of a lens. I mean magnifying power of simple microscope. We should remember these formulae with respect to respective case to solve the numericals. Getting what I mean to say? You should remember these magnifying formulae. These are very helpful to solve the numericals, and even you should know how those formulae came. Okay. Now first case, the magnifying power of a simple microscope when image is formed at D point, at a near point. Magnifying power is nothing but how we already defined. It is a ratio of height of the image to the height of the object. In same way, instead of saying height of image to the height of object, that height, whatever is there, with respect to that, it is going to create one angle at the eye. It is going to subtend one angle. Now here we are going to call that magnifying power as, see here, it is defined as the ratio of visual angle subtended by the image at the eye. Here I have written visual angle made by the image at eye with instrument. With instrument what? To get that image at D point we need that single biconvex lens that we call as simple microscope, that is optical instrument. With the help of that optical instrument we got the image at D point. Then at that time that image made an angle beta at the eye. Getting what I mean to say? See here. So now visual angle made by the image at the eye with the instrument, this diagram, to the ratio, that is ratio to the visual angle made by the object at eye without instrument, that already exists. If you remove this simple microscope, if you remove this lens, then you are unable to see this AB object. Already I said. To see that what we imagined that object shifted to near point. We imagined that object is shifted to near point. When we place that object at D point, then only we can see that. Okay? Yes, we shifted. That AB is object. We can see now. That AB object with its that height, it is going to subtend or it is going to make an angle at eye. That angle we call as alpha. Alpha is the angle made by the object at the eye without instrument. Here we have not used that additional biconvex lens. Getting what I mean? That's why I have here without instrument. Now you see here. Then M is magnifying power. Okay? Yes. How much it can able to produce the magnifying image. That is magnifying power. See here. That is beta by alpha. Beta by alpha. I have taken tan function to them. If we imagine those angles are small angles, then tan of that angle is that angle. On that concept, we are going with tan function. Okay, tan of beta by tan of alpha. Now you apply, see here, tan beta. Look on this diagram. This is beta. Beta is here. Okay, here, look here. See what I mean is, this is O point, optical center. There are two right angle triangles, OAB. OAB, this is right angle triangle. For this right angle triangle, this is 90 degree. Okay, OAB OAB. One more right angle triangle is there. O A dash B dash. Getting what I mean? These two right angle triangles are similar. That beta is common for both. Getting what I mean? Now tan beta, tan of this beta, tan function is opposite by adjacent. Opposite is what? AB. Tan beta. To this beta you apply tan function. Opposite by adjacent. Opposite is what? AB. Adjacent is what? OA. Here I have written AB by U I have written. Why I have written U? OA is nothing but which distance? Object distance. That's why I have written U. Getting what I mean? Tan beta opposite by adjacent. AB by U. Here I have. Similar. Tan alpha in this tan alpha. This is also right angle triangle. Tan alpha opposite by adjacent. Opposite is AB. Adjacent is D. That is AB by D. Getting what I mean? AB by D. Then AB got cancelled. AB got cancelled. Then you take this D in the numerator. It will be D by U. Okay. Now you see. As we know, there is a length formula. 1 by F is equal to 1 by V minus 1 by U. Okay. Now apply sign conventions. Focal length. Focal length of biconvex lens is positive. Focal length is what? It is the distance between optical center and principal focus point. This is converging lens. Its principal focus is here. Okay? Or they coming and converging here. This is like this. This is positive. This distance is positive. Okay? Yes. So now 1 by F as equal to 1 by V. V is what? Image distance. Where is V here? Where is image? A dash B dash is the image. This is the image distance. That distance is D. That you are measuring in this direction. Opposite to the direction of incident light. So that D we have to take as negative. Getting? That we have to take as minus D. In place of V I have written minus D. Okay? Then minus as usual. 1 by U. In place of U, I have written minus V. Why? Object is this side. Measurement is in this side. Opposite to the direction of incident light. So U is also minus. Minus V. Look here. Minus minus. It will be plus 1 by U. This I have sent this side. 1 by U. Minus minus it is plus. Plus 1 by U. I sent this side. This also become plus 1 by F plus 1 by D is equal to 1 by U. Here I have written. This I am going to use here. That magnifying power is M is equal to D by U. D by U. That I have written in this way. D into 1 by U. Nothing but D by U. D I have written as usual. In place of 1 by U, I have written this one. 1 by F plus 1 by D. Then you multiply this. D by F plus D by D. Finally, I have written like this. D by D is 1 plus D by F. M is equal to 1 plus D by F. This is the final formula. This is the magnifying power of the simple microscope when image is formed at D point, at near point. Have you understood? Yes. After this one, next one more is the second case. When image is formed at far point, I mean at infinity. See, look here on this diagram. Object was between optic center and principal focus. That's why virtual erect image is formed somewhere here. Now we want that image at infinity. To get this image at infinity, we have to place that object at its principal focus point. When object is at principal focus point, then image will be at infinity. that diagram I have brought here. Look, AB, same diagram, this is lens, here there is eye, okay, yes, you are observing from here, here it is eye, here you are, okay. Now object AB we placed at principal focus, I mean object distance is F, this is optic center, distance between optic center and principal focus is called a focal length, that is only here, object distance, okay. When object is at principal focus point, then obviously image is going to produce at infinity. How we can see? Look on this diagram. Take two light rays. One is parallel like this. A parallel light after refraction will pass through the principal focus. Okay. Then one more which is coming through the optic center. It will not deviate. These two light rays, 1 and 2. These two light rays, for your eye, they looking like parallel with respect to each other. These two are parallel. If they are parallel means what? They are not going to meet somewhere here. What do you imagine? These two light rays came from this side from infinite distance. Your eye feel like that. These two light rays came from somewhere from infinite distance. Your eye will feel image is at infinity. What I mean to say? Here image is there. Here image is at infinity. That image is going to make an angle beta at your eye. Beta is the angle subtended by the image which is at infinity. Which is at infinity. Getting what I mean to say? Beta is the angle subtended by image which is at infinity. Now look here. Now here, magnifying power of simple microscope when image is formed at infinity. Again, M, magnifying power. It is a ratio of visual angle made by the image at eye with instrument. I mean with instrument to the without instrument. Okay, beta by alpha. Tan beta. Tan beta, beta is here. Look here on this diagram. Beta is here. Tan beta, opposite by adjacent. Opposite to what? AB. Adjacent is what? U. That is nothing but F. Tan beta, AB by F. Okay? Yes. Tan beta is AB by F. Tan alpha, already we see. Tan alpha from this one. Tan alpha, AB by D. Getting what I mean to say? Alpha is the angle made by the object which is at D point. So AB by D. Tan alpha is AB by D. AB we got cancelled. Then this will be, see here, D by F. M equal to D by F. This is the magnifying power of a simple microscope when image is formed at infinity. Have you understood what I mean to say? You have to remember these two formulas. Okay? This is magnifying power when image is at near point. That is 1 plus D by F. Okay? M is equal to D by F. This is the magnifying power of a simple microscope when image is formed at infinity. I mean at 4 point. They will give some numericals. In that they will be asking you to solve that. They will asking you to find out the magnifying power of that simple microscope when image got formed at near point. When they say it is at near point, then to calculate magnifying power, you have to use the formula M is equal to 1 plus D by F. There D is the least distance of distinct vision, that is equal to 25 centimeter. Then they will give the F, small f value. Small f is the focal length of that simple microscope lens. Okay, you should be aware with the cases. With which case, which formula we have to use. We to be aware of those things. Okay, this is about the first optical instrument called